Hey, ninth graders, we are continuing on this journey of talking about mostly graphs, but graphs, functions, and their graphs. Today we're going to talk and continue on equations of lines. We last class covered a lot to do with equations of lines, and here's one type of line or one type of relationship of lines that I would like for us to be able to focus on today. And that's the idea of parallel versus perpendicular lines. We're going to talk about that a little bit today. We're also going to talk about something that's called an average rate of change. Remember when we're talking about a line from our notes from 3.5, we said, hey, the slope of a line is constant. It is a constant rate of change. And so what we're going to talk about today is what happens when we don't have a constant rate of change. How do we find the average of our rates of change? And we'll talk about that, which is kind of cool. Okay, so parallel versus perpendicular lines. Two lines are parallel if and only if their slopes are equal, which makes sense. If the slope is how steep something is, if you have two lines that are parallel, they have the same amount of steepness, right? So if you've got two lines that are parallel, their slopes will always be the same. Versus if they're perpendicular, their slopes are negative reciprocals. So notice that I numbered this first, negative, and reciprocals. The idea is that they're completely opposite, right? Whereas this slope right here, the slope you can count, you go up to right 3. So the slope here is up 2 over 3, whereas the slope here is also up 2 over 3. If I have my up 2 over 3 slope here, the negative reciprocal slope is going to make this number negative. And then the reciprocal means that we flip the fraction, right? If it's 2/3, it becomes 3/2. So I know that if it's going to be a negative reciprocal, this guy becomes negative 3 over 2. And you can count that here. We've got a point here and a point here. I'm going down 1, 2, 3, right? 1, 2. Slope is negative 3/2. Word of warning, a very common question that I always get is, well, what if my slope starts off negative? What if this started off negative? Well, then a negative of a negative would become positive. So if your slope is originally negative, to have a negative reciprocal, then your perpendicular slope would become positive. So it's just switching that sign. If it's negative, it becomes positive. If it's positive, it becomes negative. And then we flip the fraction. So it's like a completely opposite slope is another way to think about it. This is the only thing that we really talk about when we're talking about parallel versus perpendicular. So when you hear or read the words parallel and perpendicular, you should think, haha, slope. They're telling us something about the slope. That's a little breadcrumb. Imagine yourself being Hansel or Gretel going through the forest. It's a little breadcrumb of like, hey, follow this path. If they're parallel or perpendicular, you're like, oh, they want us to talk about slope. What happens if I go down this path in which we talk about slope? And that is the path you should be taking. So if you see or read words parallel, perpendicular, your immediate word association should be slope. All right, let's go ahead and practice. We want to write the equation of a line described in the slope-intercept form. So we want it to be in our finalized slope-intercept form. Can somebody please remind me, can all of you please remind me, what is the slope-intercept form? The slope-intercept form is in the name. It has the slope and the y-intercept, which is your b guy. So your slope-intercept form is y equals mx plus b. That's the final form that we want to be in. Remember from our last notes that that's almost never the form we start with. The form that we start with is your point slope form. Your y minus y1 equals m times x minus x1. So you're going to start with this form, and then you're going to move on to the slope-intercept form afterwards. Okay, so we're going to write the equation. We have a point that it needs to go through. So we have the point aspect of writing the equation of this line. And then we are given that we want to be parallel to this guy. And so when you read the word parallel, you should have the word association of slope specifically the same slope, which means that we need to first find, we have a point, so we have x1, y1. x1, y1 is 3, negative 8. So we know we could plug those guys in for x1, y1 here. The only thing we don't have right now is slope. But we know that the slope will be the same as this equation. So we need to find the slope here. 12x minus 3y equals 100. It's hard to tell what the slope is when y is not by itself. A very common mistake is for people to say, oh, the slope is 12. Not true. The slope is 12 only if y is by itself and then it's 12 in front of x. But since y is not by itself here, we don't know what the slope is yet, which means that we need to get y by itself. So I'm going to add 3y to both sides, subtract 100 from both sides, and then divide everything by 3. So I get 4x minus 100 over 3 equals y. Now we can say what our slope is. Our slope is positive 4, not 12. We need to get y by itself in order to determine what the slope is. Our slope is 4. And we have a point. So now we have all of the information we need in order to write the equation of the line. We start with the point-slope form because we have a point and a slope. We then turn it into the slope-intercept form. Go ahead and try this guy on your own. Find the final equation on your own. So if I plug this in, we get y minus y1 is negative 8, so that becomes plus 8 equals m is 4 times x minus x1, which is 3. In order to get y by itself, I need to first distribute 4 to both of my terms. Then I need to subtract 8 from both sides. Oops. Which makes this negative 20. Negative 12 minus 8, we're getting more negative. So that's 4x, sorry, my bad, 4x minus 20. Fantastic. All right. I want you, no, we'll do this one together. We're going to be passing through this point. Okay, so we have an x1, y1. Notice that the prepare stage of a problem-solving process is important. Writing out your variables, labeling them, defining them, saying, hey, I don't know what my perpendicular slope is because I don't know what my original slope is helpful for you to be like, oh, well, in order to find my perpendicular slope, I need to first find my original slope. I need to find my original slope here using this equation. So let's go ahead and do that. I want you to go ahead and tell me what your original slope is. In order to find your original slope, I need to get y by itself, which means I'm going to add 20 and subtract 12 from both sides. I get 16y equals negative 12x plus 20, and I'm going to divide everything by 16. Negative 12 over 16x plus 20 over 16. Negative 12 over 16 can simplify down to negative 3/4 x plus 20 over 16. I don't need to simplify the intercept. So we care about the slope, and your slope is negative 3/4. M is negative 3/4. However, your perpendicular slope, so this is the answer I was looking for, your perpendicular slope is now going to be the negative reciprocal of that. Deal with each piece. Negative means that that negative now becomes a positive, and then reciprocal means that the fraction is just going to flip. So that becomes now positive 4/3. Ta-da! We have our perpendicular slope. We have a point and a slope. So now we get to put it into our point-slope form. Y minus y1 is 3 equals m times x minus x1. Go ahead and put this into your slope-intercept form on your own. your final form should be 4/3 x plus 1/3. Okay, that is it in regards to writing equations of parallel and perpendicular lines. You've now gotten an example of each of them, which means that we're done with our examples for this section of our notes. If it's something that you're confused about, you can always go to the additional help on your resources page and practice it some more if you would like. So let's think about it in a word problem way. Slope, as we know, tells us the rate of change of a function. For example, consider the following table. We want to know what the rate of change is here. And if we have a table of values, we know that this is going to be our y values. We know that this is going to be our x values. If we want to know what our change in y over our change in x, remember those delta guys that we learned about last time? Delta means change in. How did we change? Going from 200 to 176, how did we change? Well, in terms of y, we changed by a negative 24. In terms of x, going from 0 to 1, we got a plus 1, which means that our slope is negative 24. That's it. That's all you got to do. Negative 24, though, as a slope, when we're dealing with word problems, we should understand the relationship that we have between the two variables. So not only is it negative 24, it's negative 24, and then what are our units of measure? Negative 24 what? Negative 24 Cheetos in a bag. During a change of 1 minute. So what does negative 24 mean as a slope in this context? It means how we've changed in relation to those two variables. We lose or eat 24 Cheetos per 1 minute. It's telling you a rate at which we change, right? You've talked about unit rates in the past. This is a rate in which you are changing. That's why it's called a rate of change.